Hi guys. After witnessing that the Tonga eruption is actually visible even in the logs of my amateur instruments, I decided to take a step even further and look at some other data and put that data onto a map. For those of you who may not be familiar with what happened, also you need to live under a rock to not have heard about the Tonga eruption. It's this volcano eruption here, and it's been in the news that the pressure wave, this shock wave that goes radially here, was actually recorded all around the world, and somewhat to my surprise, even my Arduino instruments recorded it. And actually this is what we are looking at. Chris Hadfield published a nice video. Let's see. It could go faster. Okay, so here's the volcano there, and you've seen the shockwave there, the volcano and the shockwave. And this shockwave is interesting because it showed up on the instruments of all meteo stations around the world. This is my data here, and these two guys are of interest. The yellow line here is the atmospheric pressure. I recorded this with a BMP 180 sensor. The resolution is 1 point per 2 minutes. It's being sent to my server, and I haven't seen the actual device for ages now, and it still does its job. And here's the data. So these two guys are of interest here. And well, this is the phenomenon in time, from one single point, from one single site. And it came to me to see this on a map here in the Carpathian Basin. And I visited the Romanian Meteorological Agency's website. I got lost. I wrote them a mail. Hi, could you help me out with some data? I have this data visualization project. I didn't receive an answer, and then I wrote to the Hungarian counterpart, the Országos Meteorológiai Szolgálat, and to my really pleasant surprise, they responded almost immediately and pointed me to the right direction. I got lost also on their website and didn't find the data, but they emailed me the right links, and the next stage was coffee, lots of coffee, and I got here. Now the text is in Hungarian. I'll explain in English what we see here. It's the meteorological stations in Hungary that do measure atmospheric pressure. It's one measurement per 10 minutes, at least in the archive. It's not the best resolution for this project, given the relatively small size of Hungary compared to the speed of the propagation of the shockwave. I also drew here the great circle. The green line points towards Tonga, some 17,000 kilometers, literally on the other side of the planet. And this is the opposite direction, and we'll see what happens along this line. The colors here, gray means there is no change in the atmospheric pressure recorded by the meteo station. Towards blue hues mean a drop as compared to the average of the previous values, and towards orange means a rise in atmospheric pressure. The moments of interest are here. Let's just click it here, and let's see what happens if I step through time in 10 minutes increments. Hop, here we can see the rise in pressure arriving into the Carpathian Basin. Here are the Carpathians, and the first meteo station recording it. 10 minutes later, it's turning orange. So we had this rather gray Hungary. First point arrives, second, and now, ladies and gentlemen, Hungary lights up like a Christmas tree. Almost all the stations record the rise in atmospheric pressure. 10 minutes later, here's the drop. Here's the pressure wave causing the rise in the measurements of southern, southwestern Hungary. And the extra visual element here is this perpendicular line. If I draw a line here, I can see that this is the front of the shockwave, perpendicular more or less to this great circle. Sorry. Here, as it is expected. So we see the shockwave coming in from Slovakia, Ukraine, Poland, and propagate towards Croatia. And it's really beautiful. 10 minutes later, we see blue coming in. We see blue progressing, and blue means a drop in atmospheric pressure compared to the average of the previous. I think I put 3 points there, so it's a moving average there. And we see that after this, there is some oscillation, and then Hungary turns gray. It's gray, little rises, little drops, nothing out of the ordinary. Until these are local changes, until this blue guy here entering from Croatia and going through Hungary. So we have this drop in pressure propagating, and then the rise, the pressure coming back to normal, some more ringing there, and then it turns back to gray, and it stays gray as the pressure here is rather smoothly changing. Also in Kolozsvár, Cluj-Napoca, where I recorded my data set. I'm here. So well, so what we've seen, the first wave coming in, a rise, a drop, and the ringing, and the second, the big drop, because this is essentially just noise here, a big drop, and then going back to normal. And we've seen this. Let's see the animation now. There, first wave, and the second. Again, first wave, and the second one. So this is it. It appears to be simple. In a way it is. Big thanks to the Hungarian Meteorological Institute, the Országos Meteorológiai Szolgálat, for pointing me to the right direction. If and when I get the data from the Romanian counterpart, I may update this map. It was really fun doing this from a safe distance from the volcano, and still being able to observe something with amateur instruments. And I'm really glad I live in this era when everything is at hand. I can play with data, I can play with visualization, and as expected. The animation is just nice. I mean, it's the real world. We see that the resolution is well, could be better, or I don't know, like on the order of 1 to 2 minutes would have been really nice. This is real life. We have 10 minutes, one reading per 10 minutes, but either way, it's still visible, it's still obvious, it's still there. And well, to me and to those that are like me, this is just beautiful. So thanks for watching, and see you next time with something else. Bye.